Hey, it ends! How's it going, guys? Guys, thank you so much. I was literally to the wire getting my YouTube video up and running, and you guys are already there, ready to go. You guys are ace. You guys are fab. Right, and yours here. You guys know exactly what's going on, and you guys are on this. You guys are fab. So, do I have Harris? There he is. Do I have Rumin? Where's Rumin? There he is. Then do I have Nick? Yo, Nick, there's Nick. I've got Ashley, got Shanley, got Anna. Look at this. Got Kieran. Is Kieran's in? Well, he sorted out his channel. Yours here. Toby. Where's Toby? Where's Toby? We're doing so well. I have arrived. There's no, that's me. I thought Toby was me because it's Toby Duncan. So we've got no Toby yet. Do we have Ben? Is Ben here? I bet Ben's not here. Ben! Where's Tong? Can't see Tong either. Everyone's running a little bit late. Got Andy. Thanks, Andy. Good to see you, dude. Victoria. There's Tong. Tong, is Ben literally right behind you? Is he logging on? Do I have Victoria? There's Victoria. Hola. Do I have Isabel? Where's Isabel? Yo, Isabel. Where's Isabel? No Isabel yet. No Isabel. Got Ruby though. Hi, Ruby. Ruby, I wasn't sure if you were going to be here. Nice to see you. Moses. Do I have Moses? There's Dom. Mr. Duncan is the best. Thanks, Dom. Dom, I don't even think you're meant to be in this lesson. That's amazing. Ben and Toby have just arrived. Look at that. Ben and Toby have rocked up. I like your mustache, by the way. Thanks, Ben. Thanks. It's a Lockdown goatee. That's what it is. Oh, do I have Moses? Is Moses in the room? Isabel's here. Got Isabel ready. Oops, is not my chem class now. No. Dom, I'm pretty sure you're meant to be somewhere else. I love that. And it immediately dropped down. That was amazing. Whoa, that is, I don't know what that means. Missing Wen, and Moses. Those are the only people I'm missing now. Oh, Moses is there. Sorry, Moses. Yo. Is Con in? Is Con in the heart? There's Con. Con was like one of the first people in the room. So is Wen. We're there. Have they gone? Wonder. Hello. There we go. Everyone's here. Look at that. Full house straight off the bat. Boom. That was awesome. Look up. I can't see you, Con. Can't see it. Oh, I'm such a nerd. Oh, lockdown's just sending me crazy. Right, guys. Guys, I have your results. Yeah. And we're going to go through the calculations test today. Yeah, I've been through everyone's answers, checked that they're all done. And today we're going to be going through them. You guys, I should have released your results, I think. I'll check that now. Let's check that I've released all your things, and then I'm gonna go through the paper. Where are my Google Forms? Google Forms. Where am I? Calculations test. There we are. Do valid email. I didn't do that. Right, phone collecting email. Right, cool. I have all the results. I think I've been through them. Have I been through them all? I'm pretty sure I have. I think I've been through them all. I've recorded all the results. Yeah, I've checked all. I have been through them all, and I think I have I released all of your release scores? Release scores. Send. Boom. Everyone has just got emailed their scores. Right, now, I need your help here, guys. By the way, there might be some errors in the marking. Don't worry. Quite happy to go through and edit that. It's not a big deal. Yeah, you guys should be able to see your own responses. Yeah. You should be able to see what you've put and then what the real answer is. And I'm going to do it with you as if I'm sitting the paper. Yeah, just to show you that even I make mistakes. It's part of life. It's part of chemistry. Making mistakes is just part of it. And so I'm going to go through top to bottom through this calculations test. And what I will also do is I'm going to highlight. Yeah, I'm going to highlight. This is where I'm trying to share screen instead of seeing my forehead. Share. There we go. We're in the house. Okay, right, guys. Here was your test. So this is the test that I made for you guys. Please, you should all now have your results. Can everyone just confirm with me on the chat that you've received your result and you can see what you've put? I don't know how this works, you see. I actually don't. You guys need to be giving me lots of feedback. Yes. Oh, cool. Unfortunately, yes. Amazing. Yes. Wait, Mr. Duncan, I haven't received mine. Toby, that's because you didn't submit it. Toby, yours is the only... Sorry, shouldn't rant. Toby, you didn't click the button submit. Sorry, dude. You are the only person who look, these are all my responses. You are the only person I didn't get, Toby. You didn't click the button submit. Lol. Sean, that's brilliant. Wait, is Mr. and a new teacher? Oh, hey, Ange. Ange, this is a year 10 calculations run through. It was from the first one that you did for me on a test. Oh my God. Wait, RIP. What the LLLL? Is that just laugh? I'm assuming that. I'm so sad I redid my test and I got them right. So I don't know what happened when I did it. That was from Ashley. Guys, do be aware. I'm understanding that this test is not the easiest thing that it's worked out. I don't know if it's worked very well or what. I do have another test if you want to have another go at it. I don't know how you redo it, if it comes through to me or what. I don't know. So there are things that I really wish ISTG. I don't know what that means. I swear to God. Oh, yeah, I'm with you. Toby, honestly, not a big deal. I'm not bothered. Yeah, I know that you did it. You were there. I had you guys all on chat. I know that you did it. You just didn't press submit. You got to admit, it's pretty funny. Toby, it doesn't mean that you're gonna have to do the other one. Oh, it's really funny. Anyway, let's crack on, shall we, folks? Everyone can see their own answers. Let's now talk. So I'm going to talk you through this, and of course, there were a couple of classic errors that everyone did. First question, calcium iodide. A couple of people misread it. I got a whole load of calcium oxides. I don't know why. No idea. I also got a calcium L. I have no idea what the L was. Yeah, I don't know what that was. But I got a couple of those. The answer, of course, is CAI2. I think most people, though, got that question. I can actually see the data. If we look at it per question, I think I can actually get the data on it. So, okay, there we go. I had 14 people with the correct answer. Somebody put an L2. Don't know what that was. So I don't know why that then marked it wrong, but I ticked it is correct. It's already been fixed. I got 1 calcium oxide. Somebody put 207. Like, that was hilarious. Well, I and L are right next to each other on the keyboard. No, they're not. Right next to the O button. Oh, Shan, do you think they've literally pressed it too quickly? Really? Wow. Lol? That's brilliant. That's actually hilarious. So I found the Mr. I found the MR. Oh, Tong, was that you? Was that Tong? RTFQ, read the full question. Come on, Tong. You're better than that. I shouldn't laugh, but it's brilliant. So I think most people, though, would be like, okay, I'm okay with formulae. Just easy mistake that. I did CAI, and then I found the MR. That's fine. Tong, don't worry about it. No, the funny part was that she put the correct answer first. Oh, I know. Next, what is the name of number 2? So we're naming this guy. So this is this is magnesium. Didn't matter if you did capitals or not. This is magnesium nitrate. Yeah, magnesium nitrate. Let's see what question 2 gave us. Question 2, I think this was really good. Look, solid answers, magnesium nitrate, magnesium nitrate. Somebody even gave me the Roman numeral, which was awesome, totally allowed. Yeah, you don't need it, but it's allowed. But one person gave me nitride, and that was Ben. So Ben, just to remind you that the 8 tells you that oxygen is present. Just a reminder. Yeah, if it was magnesium nitride, it would be Mg2 plus N3 minus cross and down. That would be Mg3N2. That's nitride, yeah, because there's no oxygen. So just a reminder. Yeah, but otherwise, nearly everyone in class got that right. Really well done. Next, what is the name of this one, right? This one was the first real trap. Yeah, do you notice that I've starred this on my sheet? The reason being is, guys, it contains a transition metal, which means you had to give it Roman numeral. And this is chromium, and the spelling did matter. Yeah, chromium Roman numeral 3 oxide. I allowed you to give any, like lowercase I was fine, capitals there or not there, fine. But the 3 was needed. Just to explain to you why, yeah, the reason being is because chromium, we know that, we need to know the charge on him. We know that oxygen is always O2 minus. I have 3 of them. Times that by 3 will give me -6, right? There's no overall charge, so the chromium must be bringing +6 to the party, but there's 2 of them. So divide by 2 gives me +3. Hard that, takes practice. Yeah, that big jump in level that. Yeah, but really lovely question. Chromium 3 oxide is the correct name. Yeah, if we look at the answers that we had on our data, yeah, if we look at the answers, yeah, there we go. Good job, 2 people getting it 3. That's 3 right, 4 right, 7 right, all good. And then look, the people who got it wrong. So 10 people didn't remember to include the Roman numeral. So don't worry, like guys, it's an easy fix. You'll remember next time. Remember, if you ever get given something to name, yeah, something to name, and the metal is in this block, you must include a Roman numeral between 1 and 7. Yeah, just to remind you, yeah, Roman numeral is required when naming anything within that block. Just something to be aware of. Yeah, next, calculate, right, so I've got to do this now on my calculator, get my calculator out ready. So calculate the relative molecular mass of bromine molecule. Right, so we know that bromine travels around in pairs because it's an ene. Anything that ends in ene travels in a pair. We find bromine on my GCSE periodic table, and bromine is 80 and 35, I believe. The top number is the mass number. It's traveling around in a pair, so 80 times by 2. Yeah, I'm just going to get rid of the 35. 80 times by 2. The answer was 160 for the molecular mass of bromine. Next, what is the relative, right? So now it gets much harder. So a nice easy formula, easy molecular mass, and then we drop into a formula mass because it's ionic. Yeah, but it's actually a hydrated. This is a much bigger, much more challenging question. Yeah, much more difficult. So now we need to count everybody. We've got magnesium there at 24 on the GCSE. Then we've got, oh look, this is clever, 2 nitrogens plus nitrogen 14 times 2. Then I'm going to have to add that to oxygen 16, but there's 6 of them. That's the really hard one. Oxygen is 16 times 6. Yeah, and then plus, right, and there's 6 waters, and everyone here knows that water is 18. We got used to this now. So we've got plus 6 times 18. So run that through a calculator. 24 plus brackets 14 times 2, close brackets, plus 16 times 6, close brackets. Oh, I forgot a bracket. Easy to miss a bracket. Oh, and now I've half starting. 16 times 6, close brackets. Yeah, plus brackets 6 times 18. Total number 256 is my answer. There it is. I think a lot of people, the most common mistake on that question is the miscounting of the oxygens. There are 3 inside the bracket, but then a 2 outside, so they multiply. Most common mistake is that one. Other people, of course, just forgetting to times the water by 6. Very, very common, but great question though. Next, if you're asked to name that, by the way, that is hydrated magnesium nitrate. That's the name of that one. Next, a percentage composition. What is the percentage composition of iron in iron 3 oxide? So rust. So this one, of course, is clever. We've got 2 irons, and iron is 56 on the GCSE table, times by 2. So the wanted over the total. So I need to have the 2 56s again, times by 2, plus oxygen at 16 times by 3, and then times by 100. So I've got 56 times 2, which gives me 112. 112 over, I'm just separating it out, splitting it up. 112 plus brackets 16 times 3 gives me 160. So times 100, I'm just working out those numbers, guys. That's all I've done. So 112 over 160 times 100, and I get exactly, now I think the question said 3 sig fig, so you had to give the decimal place at the end. Yeah, that one's a very common mistake. Lots of students forgetting that 0, but I actually think I gave it to people if they just wrote down 70 in that particular case. Yeah, it was really the test of the percentage yield, percentage composition rather than the 3 sig fig in that one. Right, much harder one now. Yeah, they went from this, by the way, this is called level medium. This here is a level 5-6 at GCSE. Yeah, and then all of a sudden a big jump up. So this one here is going to be I should level all of these actually. So potassium iodide is going to be a love 3, love 2, 3. So a simple giving formula. No, it's a bit higher than that actually. It's a 3, 4 to give formula. If it was a naming, it was a flipping it, it's lower. This one's a little bit easier, but it's a nitrate, not a nitride. So it's a little bit trickier again. So that then again is another love 3/4. Then this one now jumps in level. This now jumps to a level 5/6 for the remembering the Roman numeral. Then we had to remember that bromine was a molecule at 160. So that again is a love 5/6. Then this formula mass was much harder. This was a love 7. Yeah. And then percentage composition of iron in iron 3 oxide. That actually is a lower level, 5/6, than the previous hydrated one, because there were so many options for a mistake here. Yeah, so harder question. Next one, this then jumps, of course, then to a level 7, 8. What is the percentage of water in hydrated copper sulfate? On the chat, year 10, can somebody please tell me the color of that, please? And meanwhile, I'll work out the percentage. So we've got 5 waters, and we know that H2O is 18. Yeah, so I've got 5 waters. Each water weighs 18. That's wanted over total. So I've got to now add up everything together. Copper is 63.5 on the table, plus sulfur at 32. Sulfur at 32, plus oxygen at 16 times by 4. And then you've got to add your water again, 5 times 18. Yeah, wanted over total. Well done, guys. It is blue. Ben, it's not white. White is the anhydrous. So just to remind Ben, CuSO4, that one there, that there as a solid is white. Yeah, but then when you add water, it becomes hydrated and turns blue. It's nice to remind ourselves. Chemical tests, test for water. It's the test for water. So what do we now get? So I think 5 times 18 is a good place to start. So I'm going to try, by the way, times 100, of course. So that's going to equal 90 over, what's that whole thing at the bottom equal? 63.5. I do believe it's 249.5, I think. But I'm going to run it on the calculator anyway. 32 plus 16 times 4 plus 90 gives me plus 90. 200, I got it wrong. 249.5 times 100. Yeah, and what do I get as my percentage? 90 over answer times 100, and I get to 3 sig fig, 36.1. The reason being is it's 36.07, so it rounds up in 3 sig fig. Lots of people forgot that one. Very easy mistake to make. Yeah. Next, balancing the equation. I did wonder why lots of people, I'd love to know. Question 8, let's have a look at the data. Yeah, question 8. So that's a very important one for me to check. Yeah, I feel like I've still got kids struggling to balance the equation. 12 responses gave the correct one. Oh, 14. Yeah, in fact, how many people got it wrong? 2 people, only 2 guys. I don't know. Somebody put I don't know. Ananya, okay. Needs to practice her balancing equations. Not in this class, I believe. Wrong class. Yeah, I found H2, not H2O. Oh, so close, Ruby. Ruby, remember, I'm not bothered by your answer. It's all about making improvements and progress. That's all. It's all I care about. Your chemistry is good. Yeah. One person who there, Moses, you need to practice balancing your equations. If you want a worksheet, please let me know. Yeah, I'm happy to give you one. But otherwise, guys, really pleased. Yeah, let's go back to my notes. So to balance this, to balance it, we've got 1 aluminium, 1 aluminium. We're good so far. 2 fluorines, 3 fluorines. Common denominator is 6. Make that a 2. Make that a 3. Right, I've changed somebody. Start again. 1 aluminium, 2 aluminiums. Put a 2 here, and we're good. 2 aluminiums, 2 aluminiums. 6 fluorines, 6 fluorines. I'm good. There's my answer. Does take practice. Next. Right, now we're getting into our moles. So, number of moles is grams over rams. Yeah, nice and easy this. So we had 28 grams of water, and everyone knows that water is 18. But it says, give your answer to 3 sig fig. I've got a feeling that people are going to have stuffed up on 3 sig fig. Grams over rams, 1.56. And there's my answer. Mole, if you like, but you didn't need it. Didn't need the unit, but it's mole or moles, whichever one you want. 1.56. Nice and easy. Yeah, it's the 1.55, I think, is the common answer, but it's rounding up to 3 sig fig. Next, right, we're into gases. Number of moles is, and it's in centimeters. So I need to remember that. V over 24,000. Lots of people did over 24. It was a trap. It's in centimeters cubed. 650 over 24,000 because I'm in centimeters cubed. 650 over 24,000 gives me 0.0271 to 3 sig fig moles. Yeah, easy mistake. Lots of people giving me 27.1. Yeah, where they're out by a massive amount because they've forgotten the 1,000 bit. Yeah, and again, rounding errors. Next one, into a different one. So we've got volume, we've got concentration, we're after moles. So number of moles equals C times V over 1,000 because I'm in centimeters cubed. Yes. So input my data. Concentration is 0.25 times by a volume of 150 all over 1,000. Gives me 0.25 times by 150 divided by 1,000. Nice and easy. 0.0375 mol. There we go. Nice and easy. Yeah. And they're getting steadily harder. We're just introduction of moles. And I walked you through every mole calculation that you guys needed. Every one of them. Okay, it's starting to get harder. Now we're getting into reacting masses. Level's about to jump, guys. Yeah, so all three of these are love 6. They're all level 6s. Yet there was no real complication. You had to extract the data and you had to know your equation. These are not given to you in the exam. You've got to know them. Hence the level 6. If they gave you the equation, then it becomes a level 2, 3. Yeah, but you're not. You're not given it. You've got to apply it yourself. Yeah, I'm actually going to put 5, 6 for that one. Okay, about to see a big jump. Level 7, straight away. Yeah. So we are now getting into it's actually level 7, 8, reacting mass. Yeah. So it says if you are given, right, and what I'm going to do is these are now just reacting masses using the 3 equations we had previously. So I've got 2 SO2s plus O2 goes to an equilibrium made no difference whatsoever. I don't care. You are given 1,200 centimeters cubed of oxygen. What volume of SO3 am I going to make? Right, get to moles. Number of moles is V over 24,000 because I'm in centimeters cubed. 1200 divided by 24,000 gives me 0.05. Next, what volume of SO? So what's the ratio? The ratio is a 1 to 2. So I'm going to double it times by 2, which gives me 0.1 moles of SO3. Right, reorganize my equation for volume. So number of moles times 24,000 is going to give me V. So I'm going to multiply that by 24,000 and I get an answer of 2,400 centimeters cubed. There we go. Isn't that nice? So there's my final answer. I'll get rid of all the working out now. Yeah, so there's my final answer, 2,400. Cool. Next. Okay, and yes, that is now a level 7-8. Yeah, level 7/8. Same thing again. Level 7-8 again. So you realize that the test was, pitched at a higher level in the latter half. Yeah, you could have got all the way up. You could have got 50% on the easier questions, though. These ones are designed to be more challenging. This is why I want you guys to realize that if you've done, 50% is not a bad answer. It means we've got work to do, but, I'm targeting you guys at really very high level questions here. Right. So 25, I'm going to rewrite out the equation because I do find it handy to have so I can scribble all over it. Yeah, I'd kind of expect that you guys would have done the same thing. So it says 25 centimeters cubed of phosphoric acid. So I'm going to put 25 centimeters cubed underneath him. Reacts with 19.6 centimeters cubed of 0.25 moles / dm cubed of sodium hydroxide. What is the concentration conc of the phosphoric acid? Right. Okay, get to moles. I've got everything I need here, folks. Yeah, number of moles equals C times by V over 1,000. Run it through. Concentration 0.25 times by 19.6. Gives me all over 1,000. Gives me 4.9 times 10 to the minus 3. The ratio is 3 to 1. Divide that by 3. Yeah, divide that number by 3. And I get 1.63333333 times 10 to the minus 3. I'm going to keep that number on my calculator. Right, I've now got moles. Right, reorganize my equation. I want concentration. So moles bring the 1,000 up, times by 1,000, and bring the V down. Over V gives me C. Right, input my data. 1.633333 times 10 to the minus 3 times 1,000. I'm using the number on my calculator. Divided by 25 gives me, right, concentration is 0.0653 moles per dm cubed. And we're done. So there's my answer. There we go. It just takes practice. That's all this is doing. Yeah, just everything takes practice. Next. Okay, so the next one, question 14. How are we doing for time? Doing well. So this one, by the way, and that was, again, another level 7/8. Yep. Okay, number 14. This is actually, now, just to tell you, this one bumps up a level. This is your first level 9. Yeah, this is a love 9, folks. Suddenly realizing I should totally keep all the loves. Should keep all the love. Keep all the love. Sorry, it's me singing. These are level 5s. Love 5, love 5, love 5. Yeah, it's 5, 6. I've put 5, 6 over there, but it doesn't really matter. The balancing equation one, this is a love 4, 5. It's low. Yeah, the percentage composition, this one was quite hard. That was a love 6. Yeah, percentage composition. This one's lower. This is a love 5, level 5. Relative formula mass, there's another love 6. Yeah, and then bromine molecule, love 5. Really love 4, really. It's a love 4, really, 4, 5. Yeah. It's always nice to keep the loves. Everyone should keep the love. Next, this is your first level 9, folks. Question 14 was tough. Yeah, the reason being is I made you use 2 moles equations. So let's write down the equation. Sodium plus water goes to sodium hydroxide, 2NaOH, plus hydrogen gas. Balance the equation, of course. It's already done for you. Right. So 68 grams of sodium, put that under there. 68 grams of sodium reacts with water to produce hydrogen gas. What volume of hydrogen gas am I going to make? Give your answer in dm cubed 3 sig fig. Right. So number of moles, grams over rams. What's sodium? Sodium is element number 11, has a mass of 23. So 68 divided by 23 gives me 2.96 moles, but keep it on my calculator because it's actually 2.95652021739. Yeah, what's the ratio? The ratio is a 2 to 1 of what I want. Divide that number by 2. Gonna get 1.48. Keep the number on my calculator. Moles. Next. Right, now I want volume. Number of moles is V over 24, and it wanted it in dm, which means I'm using 24, not 24,000. Reorganize for V, bring the 24 up. So, reorganize number of moles times by 24 gives me volume. Right, so I'm just going to multiply that number by 24, and I get an answer of 35.5 dm cubed. There we go. Yeah, everyone okay with that? That one's a level 9 because it's a switcheroo in using them different moles equations. That's tricky, that, folks. Yeah, something to bear in mind. Next, question number 15. So, okay, dropping us into empirical formulae. Compound X contains 54.5% carbon, 9.1% hydrogen, and the rest oxygen. Right, first thing I've got to do, what's the percentage of oxygen? So 54.5 plus 9.1, 100 minus answer gives me, so lots of people just forgot oxygen. Yeah, they didn't finish the question. RTFQ, read the full question. Yeah, now we need to convert the symbol to grams. Yeah, change to grams. Next, count the atoms. Count the atoms, get to moles. I'm counting atoms, so it's just straight off the table. Carbon is mass 12. Hydrogen, of course, is 1. Oxygen, of course, is 16, because you're counting atoms, not molecules. Yeah, we're trying to find an empirical formula, which is the actual number of atoms. Right, let's run that through. 54.5 divided by 12 gives me 4.54. Next, 9.1 divided by 1 gives me 9.1, because I'm an idiot. 36.4 divided by 16 gives me 2.28. Divide them all by the smallest. 2.28, 2.28. Right, and I get 1, 2, I'm assuming. 4.54 divided by 2.28 gives me 1.99. Yet 9.1 divided by 2.28 gives me 4. So my final answer for question 15 after all that is C2H4O. Now you guys, a lot of students did some silly things where they were putting the numbers in the wrong place. Your actual answer on the form would have looked like that. Yeah, some people had moved the 2 in front of the C. You just got to remember that it goes after it. Yeah, it's something to bear in mind. Yeah, okay. I'll get rid of all that now. Right, nice to see it though. Next, so that, by the way, level 7, that one, empirical formula, level 7. Right, this one jumps a level 7, 8. Yeah, because it's got the extra extension. It says compound Y has a relative molecular mass of 84, and it contains carbon and hydrogen, no oxygen, carbon at 85.7%, and hydrogen at 14.3. That makes total sense because it adds up to 100. That's okay. Right, change the percent sign to a gram sign. Yeah. Now I need to get to moles. Count the particles. Moles allows us to count particles. Over 12, because carbon weighs 12. Over 1. Well, that's 14.3. That's easy. 85.7 divided by 12 gives me 7.14. Right, divide them all by the smallest. Yeah, divide them all by the smallest, and we get 1 and 2. So the empirical formula, and I think this is the mistake people made, is they stopped there. We're not finished. It's asked us for the molecular formulae, and it's told us its weight. Well, how much does the simplest version weigh? This one weighs carbon 12 plus hydrogen 1 times 2. This weighs 14. The real one weighs 84. Well, what did I divide it by? If I do 84 divided by 14, 84 divided by 14, and I get exactly 6. Multiply up everything. C6H12 is my final answer. Yeah, you just got to multiply each of the numbers in the empirical by that number. Yeah, I'll get rid of all of that. Just so as I can keep my answers. It's just nice to kind of, I'll leave that there just so you can see that. Right, question number 17. Nitrogen, hydrogen, okay. So it says I'm going to write the equation out again. This is the Haber process. The Ostwald process is for making nitric acid. I'm slowly getting there with that one. Contact process for sulfuric acid. Just reminding myself of process names. Forget them. Right. In industry, 14,000 kilograms are used to make ammonia every hour. What mass of ammonia is made per hour? Okay. It's a reacting mass. Step 1, grams over rams. Yeah. So grams over rams, right, I need to convert it. I need to times that by 1,000. That's 14 million grams. How much does hydrogen weigh? Well, hydrogen is in a pair, which is H1 times 2. So it's over 2. Yeah? That means I'm going to have 7 million moles of hydrogen. This is industry. 7 million moles every day. The ratio is a 3:2. That's awkward. It's a love 8, this. 7 million, count my zeros very carefully. 7, 1, 2, 3, 1, 2, 3. There we go, 6 zeros. Divided by 3, yeah, get it to 1, times by 2. Times by 2. So I get 4,666, 666, dot 666. You get the point. Yeah, but I'm going to keep that number on my calculator. That's the moles of ammonia in an hour. Right, now we need to get to mass. Number of moles is grams over rams. Reorganize for grams, times that by rams. Right, so reorganize that. Moles times rams gives me grams. How much does ammonia weigh? Ammonia weighs 17. You've already used the 2. People were doubling it. Don't. Ammonia weighs 17. Nitrogen is 14 plus 3, 1 each for hydrogen. Yeah, so I'm going to do that number there, multiplied by 17, the mass of ammonia. I'm using the number on my calculator, and I get 17. I'm going to divide that by 1,000 to put into kilograms, and a 3 sig fig, 793. Now, the real answer is that, but that's the wrong answer if it's the 3 sig fig. If it's 3 sig fig, it's that. There's my answer. Is everyone with me so far? Good. I know it's hard, folks. I know. Takes practice. Yeah, there's my answer. Next, number 18. Still got 15 minutes to go. Doing well. Question number 18. Right, a student heats 10 grams of magnesium in a crucible and produces 15.5 grams of magnesium oxide. What is the student's percentage yield? Right, clever. MG, because this one is, again level 8. It's not quite a level 9, but it's nearly. Yeah, plus O2 goes to 2 MgO. Right. So I had 10 grams of magnesium, and he made 15.5 grams. This is actual. This is practical. The question is, what should he have made? So I need to do, so first of all, grams over rams. Magnesium weighs 24. Yeah, so 10 divided by 24 will give me moles, 0.416. Actually, no, 17, actually. Keep the number on my calculator. The ratio is 2:2. That's nice. What that means is I'm going to have the same number. Yeah, 2:2 ratio. Right, now how much does magnesium oxide weigh? Magnesium is 24 and oxygen is 16. Yeah, total is 40. So multiply that number, and I've kept that number. I'm not using 0.417. I'm using 0.4166666 times by 40 gives me, I should have made times by 40, the rearrangement of grams over rams, and I get 16.5 16.666667 grams, so 16.7 grams. That's theory. And he made 15.5. So 15.5 divided by answer, we know percentage yield, percentage yield is actual. It is actual yield over theoretical calculated yield, theory yield, times 100. So I have 15.5 divided by 16.666667 equals times 100, and this was a trap. Because it says in the question, give your answer to 3 sig fig. Oh, I'm wondering how many of you guys are going to kick yourself. On your calculator, it spits out 93, and loads of people are going to lose that mark. Because to 3 sig fig, it's 0.0. That's a typical Edexcel trap, because the calculator removes the third decimal place, the third significant figure. That's really clever, that. There we go. Did anybody on the chat, guys, did anybody put 93 and they meant to put 90? Have a look. Question 18. Let's have a look at question 18, shall we? See how many people forgot the 0. 18. There we go. 5 people remember. Yeah, oh, 6 people remembered. Whoa, dear. Oh. Shouldn't have got it. Oh, no. People are going to lose marks. It's not good. Some people went mad. Mad. Mad, mad, mad. I've been nice and given it to you for 93. Oh, whose is that one? Whose response was that one? And Nanya, she can have it now. So I've given it to everyone else, so she can have it as well. That's an interesting one. Who did that? Ben. Ben, what did you do? You used a rounded number, didn't you? That's what you've done, Ben. You've rounded too soon. I'll give it you. Oh, I shouldn't, but oh, well. It's close enough. For you to have got that far means you're doing good chemistry. Everyone else has gone mad. Mad. Hard question, that, though, folks. Really hard question. Next. We're on to the last 2. Yeah. So 5 grams is heated to constant mass. What is the value of X? Right, guys, the last 2 are both level 9s. Both very hard level 9 questions. I did that for question 18 and 20, so the final answer is always slightly off. Ben, you can have it. If you've managed to get really close, I'm going to give those to you, because in reality, I'm not looking for the rounding errors are a nightmare, and it does take a bit of practice not to do them quite so much, but it happens. And usually they tend to give you a little bit of leeway on them, unless the question specifically says, as I said, I'm less worried about that, honestly. Next, 5 grams. This is a hydrated, heat until constant mass. So I'm going to split it in half. Calcium sulfate, line, water. Right. I had 5 grams of the whole thing. And then when I heated it, the water leaves and I have a constant mass. So that that there is what's left behind. The water evaporates, and that's what's left behind. Right, we can now work out the mass of water, can't we? 5 grams minus 3.59 gives me 1.41 grams. Because we know that the whole thing together, with the water, the whole thing weighed 5 grams. When we heat this, the water evaporates, and we're left behind with that. So anything that's gone must have been water. Right, now what we need to do is we need to get to actual whole numbers. We need to count particles, get to moles. Everyone knows water weighs 18 by now. The question is, what does calcium sulfate weigh? Calcium is 40, sulfur is 32, and oxygen is 16 times 4. Total number, no idea. 40 plus 32 plus 16 times 4 gives me 136. There we go. Right, let's work out moles. 3.59 divided by answer gives me 0.0264, but I keep that on my calculator. Actually, it's not going to matter in this one because the rounding error will disappear because we're giving a whole number as an atom. So that won't actually matter in this case. 41 divided by 18 gives me 0.0783. Divide them all by the smallest, 0.264, 0.0264. Made a mistake there, easy to make a 0 vanish. So that's 1, that's easy enough. 0.0783 divided by 0.0264, and I get 292.9697 actually, if you round it, which is 3. So the value of x is 3. Winner. Cool. X is 3. I'll just put x equals 3. Next. Let's get rid of all the working. I know that, I mean, you can always watch back the YouTube video if you want to make the notes, or pause it whenever you like. You don't really need me to keep these notes. Yeah, you can always pause the video and take as much time as you need to, guys. We've only got 9 minutes left. We've done really well, though. Right, hardest question on the board. Just to let you know, this is a grade C at A level. Isn't that amazing? This is a grade C at A level, folks. So when you get to that last one, if you're doing this, guys, then you are working at an A-level standard. And I'm really, really pleased with that. Let's have a look. So let's write out the equation again, because I'm faffy like that. Goes to Na2O, 2 and a 4. 60 grams of sodium is heated in 50 grams of oxygen. What is the mass? So it's an excess reagent. We've got to realize which one do we not care about? Get to moles, grams over rams. Sodium on the periodic table is 23. Oxygen on the periodic table is 16, but it's in a pair, so times 2 at 32. Remember, you're never allowed to leave that answer there. So 60 divided by 23 gives me 2.61. 50 divided by 32 gives me 1.56. It would appear it would be that one would be in excess. That's what it appears like, but let's check the ratio. The ratio is 4 to 1. That's awkward. Right, we need to cover somebody up. Cover somebody up. Let's cover him up. That's not working. Let's cover him up. There we go. I've covered him up. Right, this is how many moles I've got, and the ratio is 1 to 4, so divide by 4. So 2.61 divided by 4 gives me 0.653. Right, how much do I have? I have more than that number. That is in excess. So I now ignore it. Isn't that funny? It's reversed. I've got more than I needed. Yeah, it's because it's in a 1 to 4 ratio. That's hard, that takes a bit of faith. So this one is now in excess. So let's scrap it. Excess. See what I've done? I've crossed it out as excess. I'll shut up now. Right, so now that I've figured out he's in excess, this is the number I want. And I don't want a rounding error. So I'm going to run that again. 60 divided by 23 gives me 2.608695652. Right, what's the ratio? It's a 4 to 2. So I'm going to divide that number by 2. That gives me 1.30. It's actually 30 moles, but I've kept it on my calculator. Right, what does that weigh? Sodium is 23, but there's 2 of them, plus 16 times 1. Yeah, so let's add that up. I'm going to lose that on the I'm going to have to do the calculation again. 23 plus 16 gives me 62. That weighs 62. Right, I'm going to get a rounding error now, folks, on my calculator, so I'm going to run it through again. So I'm going to run it all the way through again. 60 divided by 23 gives me the full number. Divide that number by 2. Now multiply it by 62, the rearrangement of grams over rams, and I get 80 point. I'll actually show you guys. So I've times that number by 62, and the final answer to 3 sig fig, incredibly tough, 80.9 grams. Hardest question, grade C at A level. If you're being able to get that last question, guys, then you are doing incredibly well. That brings us to the end of the lesson. Now, let's go back to there, go back to that one. Guys, we're done. We're done. Woo! I know it was a long lesson, year 10. I know it was, but it really, really is good value. We've actually only been streaming live for 49 minutes. I almost got it. I don't know what went wrong. Oh, Ashley, don't worry. Yeah, don't worry. You're doing great. I'm so proud of all of you. You guys have been an amazing class, and calculations are hard, and you guys have really, really gone with this, and I've been so proud of you all. I have another test. I have a retest. Yeah. However, I am aware that, under lockdown, this is tough. I am going to say for everyone that it is completely optional. Yeah, you know the kind of results you've got. I think I typed the wrong numbers into my calculator. That's so common, Ashley. Can I just point out, by the way, I was expecting, it's really funny because I got the hard questions right, but the easy ones wrong. That does happen, Shan. Yeah, and Ashley, it happens. And I'm surprised I didn't make any errors then. I usually do somewhere. I bet if I went through my answers, I've dropped one on a significant figure somewhere. It's just part and parcel of chemistry. Guys, I'm so, so proud of you. You have been just the best for me, and you've done all the homework, and you've got such great answers, and you've worked so hard. I appreciate everything you've done. I'm going to leave you all be. Toby, of course, you haven't even done the test. Oh, kill me now. What's funny is, Toby, I should just send you that test out now, and you can have a go at it now and do it without the webinar, see if you can do it. It's hard. It's still hard. Even however many times I do it, I'll still get stuff wrong. Anyway, guys, I will leave you be. Have a great rest of your day. Enjoy your lunch. It's been awesome to see you. If you want the retest, send me a message. Send me a message on Hangout, and I'll just share. I'll send it to you, and you can have a go at it. And whatever result you get on the second one, or whichever one's higher, I will take the better of the 2 marks. And also, if you're wanting to really get good at calculations, send me a message. And by the way, if you need any help, if there are any questions where you're like, Mr. Duncan, I'm so confused about this particular type, give me a message on Hangout. I'll always give you a call and help. Guys, have a great rest of your day. See you soon. It's great to see you.